So let's talk about generics. So what are generics? Well, this is a very powerful language feature that allow you to create classes that are designed to operate on different types of data, but that allow the compiler to enforce type safety once an instance of that class is created. So it protects you from having class cast exceptions or mixing elements inside of a class or inside of a collection if that's not the intention. So let's dive into this by way of an example. So here I have a simple application, and whatever this application does is not important. What is important is that inside of this application, I have this class that I've defined called app object, which just does something for my app. What that thing is not really important. But an app object is something that I can create, and inside of my app logic, I may want to define and have perhaps a collection of them. So let's say I've got 3 of these. So I have these app objects, and recognizing this, or maybe the way that I want to utilize and manipulate these, I may want to develop some sort of data structure. Let's say that the way that I want to process these objects is through some sort of first in, first out, or first in, last out sort of sequence. So maybe I want to have a stack, or I want to have a queue. So I may go ahead and design a queue that is able to operate on app objects. So I may start by doing a relatively straightforward definition. I would probably want to have an array list of app objects to keep track of my items. And since this is a queue, of course, I'm going to have at least 2 operations, and we can basically stop there. I'll have an enqueue, which will take an item of type app object, and it will place that item in the collection. And I would have a dequeue operation that would return an app object. And since this is a queue, we add to the back and we return from the front. So we can return collection dot remove at 0. We're not doing any checks here for bounds or anything, but this will remove the item at the front, push everything forward, and it returns the item to me, and then I can return that. So this is my queue, and with this queue, I am able to then enqueue and then subsequently dequeue objects. So I could have a queue and then I can add items to my queue. All right, no problem. And then I could subsequently dequeue these. So maybe I want to show the item. So I would myQueue.dequeue, and I could do that a few times. All right, so this is my logic, and there's nothing magical happening here. But let's say that having worked on this project, I look at this class that I've defined, a queue, and I've made a determination that the implementation of this queue is straightforward, it's useful, it's super efficient. Let's say that before today, I've never thought, or no one has ever considered using an array list to store the collection of items. So I've determined that this queue class is extremely useful and I want to use it in future projects. Well, if I only have one or two more projects I want to use this in the future, it's probably fine to just hop in here, copy this code, and paste it in my subsequent projects. Not a big deal. The only thing I would have to really focus on, or the only thing I'd have to change, is that whereas this project, my queue was operating on app objects, it's unlikely that the future project would also be operating on app objects. It would probably be operating on some other type of object, such as a transaction object. And that's not a big deal. If I'm only working on one other project in the future, I can just hop in here and change app object to transaction object. All right, or whatever the object is that I'm utilizing in this future application. So it's not that big a deal. I can do that. And my queue should operate pretty much the same way. The problem occurs if I want to share this queue with other users. So maybe team members or other programmers, maybe I want to place this queue class on my GitHub so that others can benefit from this amazing queue implementation that will revolutionize how queues are designed because I'm using an array list. So in that scenario, the most efficient way to distribute this code, in fact, the most efficient way for even if I want to use this in my own future projects, the best way to do it is actually to encapsulate this queue inside a library. You don't necessarily want to just pass source code around. You want to place the class in a library, distribute that library, and then other programmers can have access to this by simply adding your library as a dependency to their project. The downside to utilizing a library, or one of the constraints rather, is that I no longer have the ability to modify the source code. So if this queue class was in a library that a programmer added as a dependency, they would just have to use the queue class as is. They would not be able to modify this to work on an app object, or they wouldn't to work on a transaction object, or whatever object is they're utilizing in their application. So I can fix this problem because what I can do is sort of generalize my queue class. I can say, well, instead of having my queue operate on app objects, which is very specialized and very specific, I could instead have my queue operate on any object. So the any class in Kotlin basically sits at the root of the system's class hierarchy. It is essentially equivalent to the object class in Java. So every object in Kotlin is an any object, regardless of what other type definitions or interfaces are used to specify its type. They're all based on any. So as a result, if I have an array list of type any, then I can place anything in that collection, in that array list. So I can modify my queue to basically say it starts with a collection of any objects. When you are enqueuing, you can enqueue any object. And when you are dequeuing, the item that will be returned will be an any object. So with that slight change, I've sort of generalized my class such that an instance of my queue class can be used with any type of data. As a result, right now, my code doesn't even need to be changed. And you might think, well, it's working perfectly. Well, only on the surface and only with this code as written now. The reality is, I can actually run into quite a few problems here. So, what are some of the problems that I've sort of introduced by generalizing my class to accept any object? Well, the first thing we're going to realize is that because every object is an any object, then it turns out my queue will not only accept app objects, but it will accept anything, including some arbitrary strings that I might decide to provide. Kotlin says this is fine because a string, just like an app object, is an any object. So it has no complaints. Now I have essentially two different objects, types of objects in my queue currently. And whereas println is not going to complain because it turns out I can pass pretty much anything to println and I'll get a result. If I wanted to store a reference to what is returned from my queue later on, I might actually hit a brick wall. So for example, if I had said I wanted to grab an object from the queue, but this object is supposed to be an app object, well, I can grab from my queue, but Kotlin is going to say, well, hold on there, we have a problem. You see, I'm saying I'm dequeuing, and I want to store it in this thing called my item. And even if I didn't have this line, it's you know, just to make sure. So right, as we're looking at our queue, we know that the 3 items we have placed in the queue are app objects. But Kotlin doesn't really care about that. The compiler doesn't care about this. What the compiler cares about is the return types. And right now, dequeue returns an any object, which means Kotlin has no guarantees that the dequeued object will be of type app object, and rightfully so. It should be wary because, as you saw before, it's possible that I could insert a string. Kotlin has no guarantees that what it's going to get is an app object. So I have to essentially be explicit, and I have to tell Kotlin, okay, the item you're going to dequeue is going to be an app object. And I'm going to be explicit by casting the returned object as an app object. So I'm basically saying, okay, yes, the thing that you're going to dequeue is of type any, but I am insisting, I'm letting you know that in reality, that item is going to be an app object, so you can cast it and store it accordingly. So because this is a queue, this code will work as I've written it here. I don't have any additional threads running that could manipulate the queue. I don't have a reference passed to any external function that could be manipulating the queue. So pretty much what I have here is current. But you can see where this could become a problem later on if I say dequeued all the items in the queue. Note that certainly the first 3 will be fine because I'm dequeuing from the front, but the last item that I attempt to dequeue will actually be a string. So this is going to throw an exception. This is a problem for me. Now, of course, I can write all type of logic to work around this, you know, or I can just, you know, sidestep the problem altogether if I know explicitly what the data is inside of my queue. But one could argue you shouldn't have mixed types in a collection. You know, that's not a good practice. And you might say, well, why would I even have this? Well, you have to understand that as a project gets sufficiently large, or if a project has multiple programmers or entities working on it, then it's very easy to run into these types of problems where perhaps an object that gets defined, perhaps it's ambiguous in its name or its documentation, which is its own problem, but let's assume it to be the case. And I might be using this queue to store app objects. However, a fellow developer who's working on another portion of this program is going to, for their piece, is going to accept a reference to a queue object, and perhaps they are unclear as to what type of items should be placed in the queue. So they may place a string or some other object type, thinking that this is the item that should be placed in the collection. And based on how our queue is defined, the compiler is none the wiser. The compiler won't stop won't prevent the use of the class or of the object in that way. So we've created opportunities for errors in our code. So how do we address this? Of course, the solution here is generics. So as mentioned before, generics allow us to define or implement a class that can operate on different types of data. However, generics will force you to specialize the instance of the class or the object that you create from the class at the time it's instantiated. And we do that by passing in a class reference. So let's see how that's done. Basically, what we want to do is specify that this queue is not just a queue, but it's a queue that will be instantiated with a reference to a class. The syntax we use to specify that are open and close arrow brackets. And inside of the arrow brackets, we're going to have essentially a placeholder. You'll oftentimes find the letter T. The letter T is not special, it's just convention. T for type. And if for whatever reason your queue or the class that you're applying generics to requires multiple references, then you usually will see things like U and V, and you continue down the alphabet. But in this case, we only want a single item. We're saying that when you create a queue, you're going to specify a class type, and that class type is what's going to be used to specialize this instance of the queue. It will only accept or operate on that class type. So this T is essentially a placeholder. And what we're saying is that whatever class type gets passed in, we are going to take that type and ensure that that is the type that our array list will store. Additionally, we're going to specify that our enqueue function will accept that type, and our dequeue function will return that type. We don't know what the type will actually be at the time the programmer creates an object from our queue class. They will specify it. So now, when I go back to my code, you'll note that it's saying, hey, this is incomplete. There's a problem here. You need to provide some additional info. What information? I need to specify the type using the similar syntax, except now I provide the class type. In this case, my queue will operate on app objects. Now, the moment I do that, the compiler looks at my code and it says, all right, I see some problems here. First, and probably the biggest one, is I've defined a queue that takes app objects. So by specifying an app object here, what I've basically said is this enqueue operation can only take, because I've passed an app object here, it will only take an app object here. It will only return an app object here, and this array list can only store app objects. So these first 3 lines are executed just fine, but when I attempt to enqueue a string, Kotlin says, no bueno, we can't do that. This has been limited to app objects only. It's been specialized for app objects. So this code is no good. The next thing that we run into, and this is less of a problem and more so just superfluous, we no longer need to cast. So the compiler, well, more so the IDE, is letting us know that this code is superfluous. It's not necessary. When you dequeue, you are going to get an app object. There's no need to cast it. In fact, this operation will probably not even execute. It'll probably be removed by the optimizer. So that's all we need. And this as well would be a problem. It's even letting me know the cast will never succeed because whatever comes out of here is going to be an app object if I had a 4th item, which I don't, so we'd have a whole other problem. But there's no way that I can cast an app object as a string. So it's telling me this is not going to work. So this is my queue implementation. It uses generics such that I can define a generic implementation of my class versus a general implementation, which is when I was using the any class. So I can specify a generic version of my class, which can then be specialized at the time it's instantiated. Once it's instantiated, now the compiler can enforce type safety by ensuring that I only add elements that are of the specified type, and it removes the need to cast when I retrieve an element, or at least, or in addition to that, the compiler can let me know, and the IDE can let me know long before I even compile, that a particular cast might fail because it knows the type that will be returned from the queue. So this is generics, the basics of generics in a nutshell. There is, of course, always more to learn, and I encourage you to continue to read on the topic to understand all of the nuance and capabilities of this language feature.